Okay, when we look at simplifying expressions, when we're multiplying and dividing, it's just like when we simplify fractions. Before we continue multiplying or dividing them, if they have common factors, we factor out cancel out a factor from the numerator and from the denominator. So, for example, in the first expression, the numerator has a factor of 2, a factor of x, and a factor of x plus 1. The denominator can be factored further. The x squared minus 4 can be x minus 2 times x plus 2. Notice the factors of x plus 1 can cancel. The 2's and the x's can't cancel. You can only cancel things that are multiplying other things. So this x minus 2 is a complete package. I can't just cancel the x or just cancel the 2 because it's being added or subtracted with something else within the factor. So the most simplified version of this is 2x in the numerator. And you can either keep it factored in the denominator or multiply it back out. It's up to you. For the second problem, it hasn't been even partially factored for me, so I'm going to look for the greatest common factor. So a cubed can be taken out of the numerator, leaving me with 3 minus a. And in the denominator, 2a squared, and that leaves me with a minus 3. Now, 3 minus a and a minus 3 look really similar, but think about how you'd have to change them. If you want 3 minus a to have the term that has a first, it would be a negative a plus a 3. If you factor a negative 1 out of that, then you have a minus 3. So if I want to replace 3 minus a, it's going to get replaced with both of these factors, a negative 1 times a minus 3. So a cubed times a negative 1 times a minus 3. In the denominator, I have 2a squared and a minus 3. So the factors of a minus 3 can cancel. Now here I have a factor of a squared, which is a times a. And here I have a factor of a cubed, a times a times a. So a squared cancels out 2 of the a's that are multiplying, which would leave 1 in this power up here still. So I would end up with negative a in the numerator and 2 in the denominator. For the third problem, there have no common factors, so nothing can be factored or canceled, so it would stay how it is. In part D, it's a division problem, so remember how fraction division works. We're going to multiply by the reciprocal rather than divide. So x down here cancels one of these factors of x here. Y up here cancels one of these factors of y here. A in the numerator cancels one of the factors of a here. And b in the denominator cancels one of the factors of b here, leaving that with a cube. Now, 5 and 15, if we cancel a factor of 5 from each of those, we have a factor of 3 left there. And 2 and 8, if we cancel a factor of 2 out of those, we have a 4. So I have a 4x times b cubed over a 3a times y. And there's no further factors that can be canceled, so that would be it. So this is basically simplifying, multiplying, dividing. All right, so if we want to simplify what we see here in example 2, same idea, but you have to know how to factor. So again, if you still don't know how to factor, you need to come into tutorial to make sure that you figure it out. So if I do x plus 4 times x minus 2, that's the same thing as x squared plus 2x minus 8. And then x plus 3 times x plus 1 is x squared plus 4x plus 3. And nothing there cancels, so I can't simplify it. So the answer is the same as the original. Now, what you see in part B is called a complex fraction, but just take it apart and think about what you're really looking at. What we have here is a 5a squared minus 20 in the numerator with a 2a plus 2 in the denominator as one fraction. And that's being divided by the next fraction, which is 10a minus 20 in the numerator over 4a in the denominator. Now remember that division. I want to look at this as a fraction multiplication problem, so I'm going to be using the reciprocal. And then in order to cancel anything, I need to see factors. I cannot just cancel terms of a factor. So in the first numerator, I can take out a 5, and I'll have a squared minus 4. That then factors further. So I'm going to write that as 5 times a minus 2 times a plus 2. And in the denominator, 2 times a plus 1. 4 times a is already factored, and then I have 10 times a minus 2. So the a minus 2 factors are going to cancel. Okay? 5 and 10 both have a factor of 5, leaving a factor of 2 in the denominator here. And that 2 and this factor of 4 both have a factor of 2, leaving the 2 in the numerator there. And then this 2 and that 2 both have a factor of 2, leaving only factors of 1. So I'm going to have a times a plus 2 in my numerator. And in my denominator, I have left only a factor of a plus 1. And again, you can multiply out that numerator if you want, or you could leave it like so.